Okay, today we are going to expand talking about similar figures. Actually, we're going to actually not expand, we're going to hone in on a certain type of polygon, and that's similar triangles. The date, it should be 3/26/14. Okay. This section, we're just going to talk about similar triangles. And one important thing to remember, we had talked about before, if I can find my straight edge, try to draw a little bit better triangles. Is that let's talk about some of the basic things we found out about similar figures last time. Hopefully we're a little better with that. I know it's tough for me too. It's odd for me to be teaching to an empty class and not, kind of teaching off of your reactions to whether you get what I'm saying or not. But we'll do our best. This is better than nothing. Thinking back, in case you didn't understand about similar figures. If you want to, have Mr. Dirter press pause, and so you can draw this after I'm done. But the thing we're going to talk about is the fact that if I needed to prove that triangle ABC was similar to triangle DEF. If I was going to prove that, right now with all the information you have, you would need to prove 6 total things. You would need to prove that the angles were congruent. So you would have to prove that angle A is congruent to angle D. And the other angles, you would have to prove that angle B is congruent to angle E. You would also have to prove that angle C is congruent to angle F. Okay? You'd have to prove 1, 2, 3 things. And the thing about it is, you'd actually have 3 other things you'd have to prove that these two are similar, as far as the last section was concerned. And we did an example where I said you had enough information on this to say they're similar, and this is what I'm talking about. You would have to prove that the corresponding sides were all equal. And this is kind of a combination of 4, 5, and 6 here, but you'd have to prove that the ratio of these two, that A over B, or AB over DE, would have to equal to the ratio, well, what does BC correspond to? EF. BC over EF, which would also have to be equal to AC over DF. Now, so in essence, 6 things. You have to prove these ratios are all the same and that the angles are congruent. And if you'll remember when we talked about congruent triangles, there was a shortcut. There was a way, side angle side, side side side, angle side angle, things like that. There were shortcuts to prove 2 triangles congruent. Well, there are shortcuts to prove that 2 triangles are similar. I mean, think about it like this. You know these 3 angles add to 180, right? If you know 2 of them are congruent, isn't what's left the same amount? So, you could cut off one of those right there. And you would think that if all the angles were congruent, then probably the sides might be similar, or the sides could be similar. Okay? at least for triangles. Now, for quadrilaterals, it doesn't work that way. But for triangles, if your angles were congruent, you'd think maybe that the two would be similar. Or that maybe if you had that the ratio of these two were the same and maybe two angles, maybe that would work. Well, it turns out here are shortcuts for proving two triangles are similar. And these are our theorems for this section. The first one is called AA, and then you put that sign. What do you think that says? Angle, angle, and then that little sign means similarity. It says if two angles, two sets of corresponding angles are congruent, then the two triangles must be similar. If you wanted to demonstrate that in a picture, remember how when we were doing triangle congruency, we'd draw kind of a picture to denote and label them to kind of denote what that was saying or the things that were involved with that. Well, in this one, what did we say? You have two sets of corresponding angles congruent. If you do, then these two are similar by angle-angle similarity. Your second theorem. Well, the abbreviation for it is this. I think you all can guess what this means. It means side, 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 similarity. Now, the thing about it is, remember side, side, side congruency meant that the sides were congruent. Well, if you'll remember, we've talked about this. In similar figures, the sides aren't congruent. They have the same ratio. What we do is we call that proportional. So what I say here, if all three sets of corresponding sides ratios are proportional, then the two triangles are said to be similar. Well, what does that mean? Well, this is where I'm going to use my little squiggly lines to try to demonstrate that, so you can get kind of a visual representation what we're talking about. What we're saying is that this over this, because those two correspond to each other, has to be the same as these two's ratio, and has to be the same as these two's ratio. Okay? Those ratios all have to be the same. Last one. I know you guys will love this. This one is called SAS similarity. And as you would imagine, that means side, angle, side, similarity. Now, how it works. If two sets of corresponding sides ratios are proportional, and the angles included by those sides are congruent, then the two triangles are similar. If two sets of corresponding sides ratios are proportional and the angles included by those sides are congruent, then the two triangles are similar. This one is much easier visualized than it is written down. It's kind of a pain to write that one down. Okay, it's basically just like side angle side congruency. Except instead of these sides being congruent, they're proportional. These ratios are the same. And if I was to label this A, B, C, D, E, F, you should be able to tell which is the included angle. And it is the one in between the two proportional sets of sides. So B would need to be the one, for it to be side angle side similarity, B would need to be congruent to E. And as odd as because it's different and we're not talking about these sides being congruent, it is a little odd, I understand that, but hopefully it comes back to you a little bit that we've done side angle side congruency, so you at least understand the concept of what it means for an angle to be included. So similarity means the only difference is in similarity the sides are proportional, not congruent. The angles though are still congruent in this. Okay, so what you've got now is you've got three theorems that you can use as a shortcut to determine whether two triangles are similar. Now everyone get out that worksheet. 9-3 practice, and we'll work some problems. First of all, they want you to write a similarity statement for these. And they want you to say what test you used. Okay, looking at number 1. We'll zoom in here tight. First of all, can you say these two are similar? I'm looking at it right now and I say you can. However, though, there's not enough information on here. And remember, we have three tests. First, there's angle-angle similarity. So if I have two angles congruent, I know they're similar. The other one is side-side-side similarity and side-angle-side similarity. I don't know anything about the lengths of the sides of these two triangles here. So obviously, I'm going to have problems justifying that the ratio of the corresponding sides are all the same. So really, my only shot here is angle-angle. The only problem is what's given to me, they only tell me one set of corresponding angles are congruent. So I don't have enough information. However, the nice thing is I have one of those situations I've talked about where I can actually look at a picture and I can tell that two things are congruent. And the reason is these two lines intersect. And what do we know about opposite angles when they intersect? They are congruent because they're vertical angles. So now I have two angles. So triangle ABC, A, then to B, then to C, would be similar to triangle, well, A corresponds to A, so it would be A, but instead of going to B, I would go to D, it has to be written in corresponding order, E. And then underneath here, I want you to write by, angle, angle, similarity. Okay? Press pause if you need to. Right here, I don't know anything about any of the angles, but I know a lot about the sides. Now here's one thing you have to remember here is, yes, you can go by how it looks, but you got to make sure there isn't a combination of these with these to where you don't get the same ratio every time. I would think the 8 would correspond to the 4. I'm not sure. It doesn't have to. But let's make sure. Let's see. Let's try it. 8 over 4 would be one of mine. How about 6 over 3? This 6, that 3. And then how about 4 over 2? If you'll notice, 8 over 4, that reduces to what? 2. 6 over 3, that reduces to 2. 4 over 2, that reduces to 2. So, do you have 3 sets of corresponding sides that are similar? You do. So, they are similar by side, side, side similarity. One thing though, it might be kind of difficult. You be careful that you write it in corresponding order. I know this corresponded to that. Well, however, this side corresponded to this side. So the Z would correspond to the S, because you see that's where it touches these sides that I know correspond, and the Y corresponds to the R. So my first letter here would need to be Y, and then they went to S, R went to S, so Y would then need to go to Z, X, and I've now written this in corresponding order. Number 3, well, they've given me 2 angles congruent here, haven't they? They've given me 2 sides. They haven't told me anything else. So to me, no, these are not similar. They have not given me enough information. These are not vertical angles. You know, when vertical angles, the lines create straight lines. If you notice here, vertical angles would have to look like that with those. They haven't given you enough information. They gave you a side and an angle. And they haven't given you the other S or anything like that. So, the answer is no, they are not similar. Moving right along to number 4. Okay, find the value of each variable. When I always did these, I always said, well, I need to find 2 corresponding. If these 2 are similar, I need to find 2 corresponding sides that I have numbers for both of them. And if you look, I do. 15 and what? 5. There's a ratio. I can use this to find both X and Y. So if I went 15 over 5, I need to then make sure on the top, on the other side, I put the variable that goes with it, which would be the X. What corresponds to it? 3. Now it's a matter of cross multiplying and solve. Over here, I would put Y, because the 15's on top, over 4, because the 5's on bottom. I know it doesn't look like it, but that's the way this is drawn here. Cross multiply and solve, I would get, what, 5x is equal to 45, making x equal to 9, because I divided both sides by 5. Over here, I would get 5y is equal to 4 times 15 is 60. Divide by 5. Y would be 12. Okay, easy peasy. No different on what you do here. Okay. I want you to show all your steps and work, show your proportions, things like that whenever you're doing any of these problems. We are going to do numbers 3 through 11. 14 through 17. Write problems, draw figures, show all steps, and work. Guys, you've got problems. I'm not giving you many problems to do. I'm giving you a lot of word problems. You better draw great pictures. Show all your steps and work. Okay? You're going to draw good pictures. You're going to label them. You're going to show all your steps and work. You are going to write the conditions of the problem, like on numbers 5, 14, 15, 16, and 17. Okay? Do you need to write it word for word? No, but you need to write down and abbreviate and write down the conditions of the problem. You don't need to draw the mountains on 14, but you need to draw the two triangles there. Label them, show me your proportion. Show your proportions every single time. Okay?